You know, it's kind of funny when you think about it. How do we all just agree on how big something is? How do we know that a meter here is the exact same as a meter halfway across the world? Well, we're going to unravel that whole mystery with a simple story that actually solves a massive universal puzzle.
So let's meet Deepa. Our journey begins with her and a problem I think we've all had at some point. Yep, she's grown over the year, and her school uniform just doesn't fit anymore. And this super simple, everyday issue is about to kick off a really big discovery. So when her mother takes her to get a new uniform, Deepa starts to notice something odd. The shopkeeper uses this long, stiff metal rod. The tailor, on the other hand, uses a flexible tape measure. And then her own mother suggests adding a length of char angula, which is basically the width of 4 fingers. Deepa's thinking, wait a second, 3 different jobs, 3 totally different rulers. It really got her thinking.
Back at school, Deepa tells her friends all about her confusion. And you know how it goes. This one little question about different rulers gets everybody curious. It leads them to a brilliant idea. Let's do an experiment. And they're going to use the most ordinary object they can find, their classroom table.
Her friends totally get it. They realize this is how people have measured things for, ever. A grandmother might measure cloth with the length of her arm, a farmer might pace out a field using his strides, and Deepa's mom measures things with her handspan, which is called a ballast. It's personal, it's convenient, but, as they're about to find out, it has one major flaw.
Okay, so the plan is set. The friends all gather around the table, ready to test this all out. Their tool for the day? Super simple, their own hands. The goal? To find one single consistent measurement for the table in handspans. Sounds easy, right?
So they all get to work, carefully placing one hand after the other along the edge of the table. But when they all share their results, it's complete chaos. The numbers just don't match up. I mean, they're not even close.
The results are in, and you can see the problem right here in black and white. Anish gets a little over 13 handspans. Padma gets exactly 13. And Hardeep gets a full 14. So, who's right? How long is the table really? This is the exact question Hardeep asks, and it's the absolute core of the whole puzzle. If they all measured the exact same table, how on earth could they all get different answers? And the answer, when it finally clicks, is incredibly simple. It's one of those of course moments. Tasneem is the first one to guess it. Their hands aren't the same size. Anish has bigger hands than Padma, and Hardeep's are a bit smaller. Their ruler was literally changing with every single person who used it. And that's it. That's Deepa's big light bulb moment. No wonder people use scales and measuring tapes, she realizes. Their so-called failed experiment actually proved something huge. It showed why we all need something better, a universal ruler that's the same for everyone, everywhere. And this leads us to the big solution, the idea of a standard unit. A standard unit is just a measurement that has a fixed, unchanging value. It doesn't matter if you're tall or short, or if you're in one country or another, it is always the same. And this picture just nails the difference perfectly. On one side, you have a handspan. It can be any size. But on the other, you have a ruler. That little mark for 1 centimeter is always 1 centimeter. It's reliable, it's standard.
Now, to solve this problem on a global scale, pretty much all the countries in the world agreed on a single system, the International System of Units, or SI for short. And for length, the main unit we all agree to use is the meter. And the meter is part of this really neat family that's super logical. For really long distances, we use kilometers. For everyday objects, we use centimeters. And for teeny tiny things, we use millimeters. It's all connected, which makes it incredibly easy to use.
But here's the thing. Even with a standard system, you still got to use the right tool for the job. You wouldn't try to measure around a big curved tree trunk with a stiff ruler, would you? Of course not. You'd grab a flexible tape measure. The unit is standard, but the tool has to fit the task.
And of course, using that tool correctly is absolutely key. So first, make sure the scale is placed flat, right up against the object. Second, position your eye directly above the measurement mark. Looking from an angle can throw your reading off. And hey, here's a pro tip. If the end of your ruler is broken and the 0 is gone, just start measuring from the 1 centimeter mark, and then remember to subtract 1 from your final number. Simple. So the friends have totally solved the puzzle of length. But their curiosity is just getting started. Their next big adventure in measurement begins with a brand new question, one that shifts their thinking from how long something is to where it is.
A teacher announces a field trip to a local garden, and immediately the friends start debating. Is the garden closer to us, or is the school farther away? Tasneem and Padma are totally sure the garden is closer, but Deepa and Anish are positive the school is. So, who's right?
Well, it turns out they all are. How's that possible? Because they were all measuring the distance from their own different houses. The answer to where something is, or how far away it is totally meaningless unless you have a common starting point.
And this brings us to another super important idea, the reference point. It's just a fixed object or a spot that everyone agrees to measure from. Without it, describing a position is just a guessing game. The reference point is what gives location its context.
Here is a perfect real-world example. Padma is on a bus and she sees one of those kilometer stones on the side of the road. It says Delhi 70 kilometers. In this case, the city of Delhi is that fixed reference point, and her current position is exactly 70 kilometers away from it. A little while later, she sees another stone. Now this one says Delhi 60 kilometers. The reference point, Delhi, hasn't moved, right? But her position relative to it has changed. She's now 10 kilometers closer.
And that simple observation actually gives us our final, really elegant definition. What is motion? Well, an object is in motion if its position changes over time with respect to a reference point. See? It beautifully connects distance, time, and position all in one go.
So a standard unit lets us agree on length, and a reference point helps us agree on position. But here's a final thought to chew on. We use fixed points as references, right? Like a city or a bus stop. But what happens when your reference point is also moving? Like another car on the highway. How do you measure motion then? Now that is a puzzle for another day.